to Aaron Woodhouse to walk us through the JSON object.
All right, well, welcome to day 3 of Directions 2025, everyone. In case you were unable to make my presentation on our new AI assistant yesterday, I will introduce myself again. So I'm Aaron Woodhouse, a newer developer that joined PxPlus last year. You may have met me at our Directions 2024 conference in Toronto, but I was quite new then, only having been here about a month. But this year, however, I get to share some of the cool things that we've been working on. Today, I'll be talking about our new JSON object, which was introduced in PxPlus 2025. Now, before I get into things, I'd also like to thank everyone that was part of our JSON user group. Your insights and especially the files you provided were very helpful for development, and I also hope that you get some great use out of it. Now, let's get into the details. So, to break down what topics we'll be covering about the JSON object today, I'll first give an overview of what JSON actually is, about using JSON in PxPlus, and an overview of the new JSON object. Then, we'll be going over the various methods that the JSON object has, as well as methods for loading, saving, and converting your data. This will be a big chunk of today's presentation. Next, we'll go over the new functions that will be coming in PxPlus 2025 Update 1, and after that, we'll talk about the enhancements we also made to the XML object. Following this, I'll talk about the performance of the JSON object, specifically compared to the XML object, and of course, a demo to show off using the JSON object and what a program that uses it may look like. So, as a quick refresher, or for those of you that are not familiar, JavaScript object notation, much better known as JSON, is a format of structured data consisting of key-value pairs, and is commonly used in things like web applications and APIs. You can see an example of what JSON looks like here on the top left. It has various key value pairs for an example ordering system. It has key value pairs for like the customer name, the order date, the total, and also includes a sub-object like the location and the actual order itself. JSON requires less formatting than XML, but provides similar functionality, which makes it a good alternative to XML. Okay, so let's first go over some background on using JSON in PxPlus. To work with JSON in PxPlus previously, you would need to use an associative array. An associative array also stores data as key-value pairs, where its keys are denoted as a string. The string can contain multiple tags separated by periods, which allow you to create sub-objects, which I will instead refer to as dot notation from here on, and that this can be assigned either a string or numeric value. You can then get a JSON formatted string of this array by using the dimlist edit, or just dimlist if you wanted to. And this array gives PxPlus the ability to do basic JSON data manipulation. But we can do a lot more, and this is where the new JSON object comes in. So the JSON object significantly expands upon JSON processing in PxPlus, providing new object-oriented functions to easily work with your data. The JSON object also comes with functions that allow for more advanced processing, but still behaves very similarly to the associative array, since it was actually built on top of it. However, as you'll also see later, dot notation is not strictly necessary when using the JSON object, though it is easier with it. Now, one alternative to using JSON in PxPlus, as of now, is the XML object. However, we will also see later why you may actually want to choose the new JSON object over the existing XML object, especially when it comes to performance. So to start using the JSON object, you can invoke it by simply using new start object / JSON, which will create a object handle of the JSON object. So now we can begin the more technical section where we talk about the various functions that the JSON object comes with. We'll be starting with the append functions. The append functions work by passing in a key value pair to the function, which will add that pair to your JSON data, but only if a duplicate key does not already exist. Associative arrays, and hence JSON, don't actually allow for duplicate keys by design, so if a key with that name does already exist, you will get an error 11 for trying to add duplicate data. Now, looking at the append to function, you can also append a key value pair to a specified key, which will either create a sub-object or add to an existing sub-object. If you have a second JSON object, you can also append the data from it into your current object by using the append JSON function. You simply provide a handle to the JSON object that you would like to append the data from, and it will add it to your current object. And with the append JSON 2, you also have the option to append the data from another JSON object to a specified key, kind of like the append to. So let's see a quick example of this. Here on the left, we create a JSON object to represent an employee. We use employee underscore object tick append, passing in the name of the key, which will be name, and a value of John Smith. That will be our person that we're adding. Then we can use append2 to create the sub-object called address, which will contain the key value pair of street with the value of 32 Avenue to it. And you can see what this will look like as JSON data here on the right. Now, something else you may have noticed is that the data is automatically sorted when it is displayed. We appended the key name first, but address is displayed first instead. This is a behavior that comes from using the default JV, or JSON version, system parameter, which defaults to 2. There are also functions to get values back from your JSON object. We can use the getString function to retrieve a key's value as a string. Keep in mind while using this that numerics will also be returned as a string by this function. There's also a getNum function to retrieve a key's value as a numeric, kind of similar to the getString function. Now, if the value is a string of a number, it will also convert it to a numeric automatically. Now, another option for both of these, though, is to use the ignore key validation flag, which skips the validation checking that ensures that your provided key will actually work. This actually allows for a boost in performance, but at a loss of some safety. Next, we have the getJSON function. This will allow you to retrieve an entire sub-object from your JSON data, and this will return a new object where the new keys have parent tags that are trimmed down to just the data that you need. This function does, however, come with a full key flag, which allows you to retain the full original key in case you need it. And lastly, there is a getKey function that simply returns the key at a particular index. This is mostly just helpful in case you have something that needs to iterate over each key, since associative arrays are not actually meant to be indexed. So let's see an example of this. Here, we use the getString function on the key name of our employee object, which will return the string value of John Smith. We can also get the sub-object address by using the getJSON function, which will return a JSON object that contains the key value pair for street. So similar to the append functions, we have a similar set of functions to set data. The main difference being that the set functions will overwrite existing data, unlike the appends which only add data. The basic set function is pretty simple. It will set the value at a specified key and will overwrite any existing data. We also have the setJSON function, which allows us to do the same, but by setting an entire sub-object instead. This will also overwrite any existing data. One rule to this, however, is that we can't directly set a JSON object to itself. But if either of these functions would overwrite a existing sub-object, it will also remove any existing data within the sub-object before setting the new data. Now, for those of you that prefer performance, there is actually a forSet function. Normally when you're using the basic set function, just like the gets, it will check to make sure that the key you provide is actually a valid key format. Again, this is safer, but at a cost of some performance, or more unsafe, I guess. Here, we use the function instead of passing in a flag, and it will allow you to bypass that validation when setting the key. The forSet function also comes with a flag to ignore removing existing values. This is again for those of you that prefer performance, but it will simply set a key value pair that you specify without removing any data. So let's look at an example. Here we take the JSON object from the previous example, and we set the key name to Jane Doe. This will overwrite the original John Smith, as you can see here on the right, with the new name. We can also set the address to something different. Here we overwrote the address subobject and it will first remove any existing data under the address tag, and then it will set our new key value pair. So it would be dangerous here if we did the same thing, but using the forSet function with the ignore remove flag. What would happen is it would leave behind the original address subobject, since we don't remove any existing data, nor would it overwrite it, since the full key is actually called address.street, which is different from address, which is what we're going to be setting. If you're to try and retrieve the value of address, you would get a duplicate error, since the first address would actually return the street subobject, and the second would return the value of 32 Avenue, and both are trying to be done at the same time. So next, we have our string functions. The string function will simply return a string of your JSON object in the exact same format as using the dim list edit on the associative array. We can even provide a key, which will return a string of a specific subobject. There is also a sort flag to sort the return string, but keep in mind that this is only useful when the JV or JSON version system parameter is less than 2, since a JV of 2 will automatically sort the displayed JSON data. And of course, we also have the key and sort flag version as well. In this example, we simply print out the return string by using the string function, which will look like the output here on the right, minus the syntax highlighting. There are also print methods, which will simply print your JSON data. It is identical to using the print directive with the string function that we just went over. Very similar to the last example, we simply print the string of the object, but we do so by calling the print function without needing to use the print directive. So now we can actually talk about the find functions. The find function will return a JSON list of all the keys within our JSON data that match a given regular expression. If no keys are found, it will just return an empty list. We can also specify a key to look within a specific subobject, which can help narrow your search. There's also a similar set of functions called findAny that will simply find any keys that match and will return either a 1 or a 0. An example of using the find function would look something like this. In this case, we use regex that will find any tags that start with any character, followed by the word street. In this case, it will find the tag address.street in our JSON object, and we'll add it to our return list here in the output. We also have some other functions. The clear function will clear your object of all its data, including both key value pairs and subobjects. There's a isListIndex function, which is mostly just helpful in case you have something that needs to know if a key is actually a list index or not. The isNum and isString functions will return whether or not a value of a key is a string or numeric. Note that there are actually some special values called true, false, like booleans like true and false, null, that are actually considered numerics in this case, however, must be processed like strings. And I'll go over these more later. We have the remove function, which will remove the specified key, as well as any key value pairs or subobjects within it. And lastly, we also have the size function, which will return the total number of elements or actual values in our JSON object. So next up are methods that allow you to load and save from files, and also convert your data from other data types. First, we have the load array function, which will load a associative array into the JSON object. If you already use associative arrays, you can easily convert your data to a JSON object by using this method. This function also has the option to load all the data passed in by the associative array as only string values by using the num flag. There is a load JSON file function that allows you to load data from a JSON file. There is a quick check for a open curly or square brace, which is usually indicative of a JSON file when loading the data, but otherwise you'll want to make sure that your data is actually formatted correctly before you load it. And lastly, we also have, or not lastly, but we also have a load string function. This allows you to have a string of JSON data and load it directly to the object. This is identical to how you would load a JSON string with the associative array. Now, For those of you that use the XML object, there's also a load XML function to load data from a XML object directly into the JSON object. Now, keep in mind that this will not retain any XML attribute tags, only the main tag names and its data. In PxPlus 2025, this currently does not support loading duplicate XML tags, and any duplicates will be just simply overwritten by new ones being loaded. This is primarily due to how XML data is allowed to contain duplicates, whereas JSON is not really meant to. However, I actually have more on that shortly with what's coming in update 1. It also comes with an option to load your data as only strings by using the num flag option. There we go. And lastly, there's also the there's a save JSON file function which will simply save your JSON data to a file. There we go. So let's look at some examples. First, we'll go over loading a associative array. So here we make an associative array with some key value pairs. We have my underscore array dollar with a person subobject, a street name, and a street number. We then use print dim list edit to output our data to the console here on the right. And this is what loading the same array into the JSON object would look like. We create a new JSON object, and then we use the load array function, passing in the data from my array dollar. And you can see on the right that this data is identical, but is now actually within our JSON object. So next, let's load a XML object into our JSON object. You can simply pass in the object handle for it, and it will load its data. On the right is the XML object that we will actually be loading, which is a product that has some data, a name, a price with a currency attribute, and a serial number. Here on the left, we can now see what this conversion will look like. As was noted earlier, the currency attribute tag does not actually get converted, and we will also see that the price and the serial number got converted to numerics instead of strings. We could also use the num flag here to retain the data as strings if you needed it to. So, like the associative array, the JSON object also supports lists. A list is denoted by square brackets, or rather than curly braces, and we can use the list by passing a string of a numeric as a key. So, for example, setting the key 1 to the value of first, we'll set index 1 of our list to the value of first, as you can see here on the right. We can also set a sub-object in a list. Here, we use the append2 function to create a sub-object at index 2. And if you want to use numeric keys, but not as a list, you can actually use the pound symbol before the numeric in the tag name. We can see that it creates a new key 123 without it becoming a list, and is displayed without the pound symbol. So I mentioned it before briefly, but we also have some special values that you can use. There are special cases for the null values, booleans, and empty lists. Each of these are simply passed in as a string, but when printed in the object data, you can see that these values will actually display without quotations. Now, to get these values back, you will need to use the get string, since these are technically strings. Okay, so now we can get to some of the new things that are coming in PxPlus 2025 Update 1. There's a new exists function to simply check if a given key exists within the JSON object. Another new one is the getKeys function, which will return a JSON object with a single list of all the keys within your object. We also added some no validation flags to our getJSON, getNum, and getString functions for those of you that want to squeeze out even more performance. There's also a print keys function that will simply print all the keys of the object to the console. It's kind of similar to the getKeys function. And we also added the no validation flag to the remove and set JSON functions as well. Now, coming back to the load XML function, we now have handling for XML objects with duplicate tags, which is done by simply adding a dup flag equal to 1. What this will do is take any duplicates being added and convert it instead into a list by adding a number in the tag before the duplicate. Now, this takes a fair bit of processing as it needs to move entire sub-objects around. So if you have a lot of duplicates in your data or really long subtags, it can become fairly slow. So we also added functions to find keys based on a value. It will compare the given value to the value of any keys that match the regex. If the value matches, it will add it to a JSON list. And once all the keys have been checked, we'll return a JSON object of the keys that match. You can also use the key parameter to only look within certain subkeys that will help you narrow down your search. And lastly, if you just want to know if a key within the object has a matching value that exists at all, you can use the findAnyVal function. So here we use the new print keys function to get a list of all the keys from our object here on the right. So what this will do is return a JSON list as seen in the output on the bottom, which will contain the key names from our object. Now looking at the load_XML function, we can see what it looks like to actually load XML data with duplicates. On the right, we have a XML object that will be loading. It has two orders, each with their own product. So to load this data, we will use the load_XML function with the XML object handle, a num flag of 1 to allow for numerics, and a dup flag of 1. Then we will print out the resulting data. So here on the left, we can see what this actually will look like in the JSON object. Since the order tags are actually duplicates, technically, instead we'll create a order list. Each index of the list contains data from our orders in the XML object. In this case, the first order will become order.1.product, and the second order.2.product. This actually lets us get around the duplicate limitations that JSON data typically has, and allows us to load such data from an XML object, which does allow for duplicates. Okay, now let's take a look at the new findVal function in action. We utilize a regular expression to look for any key that matches the pattern products.product, followed by any character, and it will add those keys to a return list if those tags are also equal to our value. So from the JSON data here on the right, we found the key products.product2, which has a value that matches what we were searching for. And we can see it's now been added to our return list here on the bottom left. So in the first release of PxPlus 2025, we also added some new functions for the XML object. You can now load data from the JSON object or load and save data to files. The XML object is, or rather was, the main alternative to using JSON data with an associative array, since the new JSON object is based on the associative array. We've actually done some performance comparisons to the XML object specifically. Now, as a quick side note, if any of you are currently using the XML object at all, I think you may really like this next section. So, to make some comparisons between the XML object and the JSON object, we'll be looking at both the speed and memory usage of a few functions. Namely, we'll be looking at the loading from and saving to a file, converting from one to the other, and getting a string back of the object's data. We tested this with a file containing 27,875 data entries, no duplicates, and it was about a 1 megabyte file. So let's take a look at loading from a file. To load an XML file into the XML object, it took about 21 seconds and 17.1 megs of memory. Saving to a file, it was about 6 seconds and 6.4 megs. Loading JSON data into the XML from the JSON object was much slower as it has to convert all the tags and values in JSON into an XML object format. This actually will use a JSON copy of the exact same test file. And this took about 103 seconds and 17.1 megabytes of memory. Getting the XML data back as a string took about 6 seconds and 6.4 megabytes of memory. So let's look at the new JSON object. To load from the JSON format of the exact same file, it only took 0.03 seconds and 3.6 megabytes of memory. Saving the JSON object to a file also only took 0.03 seconds and doesn't use any memory. Loading an XML object into the JSON object took about 13.33 seconds and 6.2 megabytes of memory. This uses the XML version of the exact same test file. And getting the JSON data back as a string also only takes 0.03 seconds and 1 megabyte of memory. So let's break down the metrics a little bit. We can see that the JSON object is significantly faster than the XML object. The fastest being about 700 times faster at loading a file, and the slowest being 8 times faster at converting from XML. We can also see significantly less memory usage from each of the functions in comparison to the XML version in its object. So I'd also like to take a moment to talk about the performance of loading XML data with duplicates into the JSON object, since we added the new duplicate handling. Since JSON doesn't actually support duplicates, the previous performance testing will not be applicable here. So instead, we'll be taking a look at the rate of loading data entries with just the JSON object instead. So looking at our previous testing, we had loaded a file of 27,875 data entries of non-duplicate data, and this took about 13 seconds, which gives us about it gives us a rate of 2,091 entries per second. Loading a new test file with only 5,000 data entries, all of which are duplicates of one another, took about 75 seconds, and this gives us a rate of about 67 entries per second. So this is where the main drawback of converting an XML object with duplicates becomes apparent. This conversion process is quite performance heavy and scales when you have either more data entries or if you have a lot of subtags. The load XML function converts duplicate data about 30 times slower. So if you use data with many subtags, this may take even longer, so keep in mind if you want to convert all your data from XML to JSON. Okay, so next, let's do an actual demo to show it in action. What we'll be doing is creating an invoice object that contains some data, which will be some general information that for the invoice itself, information on the customer, the shipping info, payment details, and the actual order itself. We'll also take a look at retrieving and updating values in a file that contains records of some customers. Okay. I'm going to bring up a demo. Okay. So here on the left, we have the actual code that is being run, and on the right, we have the program that is being run. So what we do is we start by creating an invoice object on line 13, right here. And then we will append some general information about our invoice to the object. We give it a invoice ID, the date that the invoice was created, a status, a completion status, and a total. When we print this invoice object, what we get, it will be shown here on the right. So next, we'll also add some information about the customer. So here we add, so here we append data in the same way, but with two different methods. First, we use dot notation to add an ID and a name to a customer sub-object. Here, I'll let you bring that up now. Secondly, we append an email and phone number to our customer sub-object by using the append to function. And as we can see on the right, this is what printing the invoice object after adding this information will look like. So now we can also add our shipping information. So first we'll create a new shipping JSON object, and we'll be using the same append methods as before. We add a bunch of data to our new object, and we can see that our newly created object here on the right. This particular object will actually contain a single sub-object with all the data, being the shipping object within the shipping object. We can put it down here. And now we can add this new object to our invoice by using the append JSON function right here. And now our object here on the right, you can see that we have our shipping data has been added to our invoice. This will take our shipping object and append its data as is, and we will also drop the shipping object since we no longer need it. So now we can also add some payment details. So what we do is we create a payment object, and rather than append, we use the set functions. Since there is no existing data, it essentially behaves exactly the same as if we were just using the appends. So as you can see here on the right, unlike the shipping object that we just did, we didn't add our data to a sub-object. We instead just added these details as key value pairs directly to the main object. And this time, when we add our new object, we use the append JSON2 function down here. And we append the new sub-object payment with the details from our payment object to our invoice. And this is what that will look like. And with that, we can also now drop our payment object. Okay. Next section. So the last bit of information that we actually want to add to our invoice is the actual order itself. We create a new order object, and for demonstration purposes, we create an empty list that will simply just get overwritten when we add some items. The items in this list are all within a list, and we are adding a product 1, 2, and 3, and also a subtotal for these items. So what we can do is we can now take this object and use the set JSON function on our invoice. Okay, so now we have all that data in. Now, let's say that our customer provided us with some new shipping information that they want to overwrite their existing ones with. What we can do is we can create a new shipping object, and then we can use the setJSON function after adding a bunch of new data, and it will overwrite the existing data under our shipping sub-object. So as you can see here on the right, that data has now been updated. Since we no longer need the object, we can also just simply drop it and continue on. Okay, so great. Now we have our new shipping information, but the customer also wants to remove product 3 from their order. Okay, so we can now update the order instead to help them out, and we can simply use the remove function on that item 3 to remove it from our data. Of course, we also want to update our order subtotal since we're removing one of the items. So looking at the right, when I hit enter, the order subobject up here will also update with our new information. So now we have product 3 gone and the subtotal has been updated. Okay, so lastly, we also want to update our invoice total to reflect the actual purchase. So what we'll need is the order subtotal, the shipping costs, and we can also get those by using the getNum function. We take those values, add some tax, and finally set our invoice total down here. And again, when I hit enter, the invoice total on the bottom of the right screen here will be updated. There we go. Okay, so we've created our new invoice and we can now process it elsewhere. The other part that we want to do though is store our new customer, John Smith, into our customers.json file. Okay, so let's create a new all customers object, and we'll be loading our file using the load.json file function. As we can see on the right, we have 2 existing customers in our file. We have Smith Jones and Jane Doe. Now, for demonstration purposes, the sub-objects are also named using the ID of the customer. So we have 312, 312, and 283, 283. So now we can get our customer that we want to add. We can use the getJSON function on our invoice object, and by specifying the customer sub-object, we can easily get our new data. Okay, so to do this, we'll get the string of John Smith's ID, and we can use the append JSON2 function to add them in. So as a quick reminder, the pound symbol can be used in front of a number to ensure that it doesn't become a list index. Since we want the ID to become the sub-object, we combine it with the pound symbol to ensure it doesn't become a list. And in this case, our append function for append JSON2 is great here since we don't actually want to add duplicate customers to our file. All right, so now we're good to update the file. But wait, you actually realize that we imported our test user, Jane Doe, into our production file at some undisclosed point. Uh-oh. So let's say we want to remove this test user, but we don't know Jane Doe's ID for whatever reason. Conveniently, we can use the findVal function. We know that the key structure to find a person by name would be some kind of digit followed by name. So what we can do is create a regular expression that does this. And what we'll do is we also pass in the value that we would like to find, Jane Doe. So what we get back is a JSON object with a list of any matching keys. In this case, we found pound312.name. This tells us that the ID that we are looking for is 312. Now, instead of doing it manually, we happen to know that there is only one user with the name Jane Doe, and we also made our program automated to fix this problem. We take the value at the very first index of our list, and we do some processing to split off the parent key pound312 from the name subkey. We can now use the remove function on the key pound312, and as you can see here on the right, our test user Jane Doe is now gone from our file. Okay, so with this issue that we had out of the way, we can now safely save our file to our customer_after.json file. Okay, so this is the file that we'll be saving to. It is currently empty. There's absolutely nothing in it. What we'll do is use the save JSON file function. Once I hit enter, we can go back to our file, and our file has now been updated with our new information. Okay, so with that, we'll switch back over to the PowerPoint. Okay, and I have one more thing before we actually finish off the section that I want to go over. We saw many performance gains using the JSON object over the current XML object, but perhaps you still want or need your data in an XML format. What we're looking into is creating a new XML object alongside the existing one that will introduce a similar set of functions and performance as the JSON object. Now, we actually want to hear from you about this first, if this is something that you would like. Real quick, if this is something that you would be interested in, you can just raise your hands in Teams and by using the little raise hand button at the top. There we go. Okay. Cool. Some interest. Okay. So for those of you that raised your hand, you'll also want to join in on Len's roadmap session later to discuss this and other things as well. All right. So to summarize everything that I've gone over today, it was quite a bit. The new JSON object introduced in PxPlus 2025 is a high-performant and easy-to-use object that lets you intuitively work with your JSON data. It comes with a variety of functions that let you focus more on the higher-level development, saving you on development time. It also comes with methods to easily load your existing data into the new JSON object, method variants that allow performance-minded developers to further improve performance, and saves you significant amounts of time just processing using the XML object. This new JSON object is available right now in PxPlus 2025 and is getting the new features that I talked about in the upcoming Update 1 release. If you want some more information, we have some resources here in the PowerPoint that will be posted later after DireXions is done. And you can find a link to our how-tos, a video library covering those how-tos, and the actual JSON object documentation. Okay, So before we end the session, do you have any questions, thoughts, or anything else that you would like to bring up? It could be about the JSON object, XML, or anything like that. For that, you can either put up your hand in the chat and we can unmute you, or you can raise your hand, or yeah, you can either put it in chat or you can raise your hand so that we can ask directly. Okay, here. All right, James. If you want to unmute, you can go ahead.
Okay, a couple of things.
Yep.
The first is when you include a pound sign as the first character of the key, you're
Yes.
indicating that this is a number, a key number value or something like that.
Yeah,
Is
we're
there
essentially making sure that it's actually a tag rather than considered a list.
okay? Is there any way to quote a pound sign in case you have a first character being a pound sign?
I'm not sure. I'm gonna have to get back to you on that one. I don't think I can competently answer that right now. So I'll look into it a bit more just to make sure I have my answer correct for you.
Okay. Item number 2, way back on page 8 for your getString method,
Yeah.
it returns a string, but the description that you had says it returns 0 if not found. So just wanted a little clarification on that.
On slide 8, you said?
Yep.
Okay. So yeah, those getString functions, if you try to use it and that kind of value doesn't exist, it'll return a 0 just to let you know that it doesn't actually exist. Um, and this 0 will
But
be a
but isn't getString assigning the strings that it returns to the variable that you're assigning it to?
like when you use the getString function. Let's say you have a variable name with a $sign equals getString of that. You pass in your key, and it will, if it can't find that, it will return a 0 as a string.
Okay. So it returns
But
a string 0, not a numeric 0. Okay.
yeah, if I recall correctly, at least based on that wording.
Okay. That's all I've
Okay.
got right now. Thank you.
All right. Thank you. All right. Next up is Martin. Do you want to unmute yourself?
Oh, there we go. Hi.
Hey.
This JSON object came at a great time. I just happened to have a third party that I was trying to get some data back, and sure enough, they were giving it to me in a JSON format. So I said, "Oh, let me try this new J object," and I was actually very impressed by the speed, as you had mentioned. I was
Yeah.
parsing through the object. I'm like, "Wow, this is fast. This is almost as fast as an array," and sure enough, it was like almost instant. And mine was only about 600 records, but still, it was just like very snappy. It didn't feel like I was parsing a file. Um, it's funny, the question that the previous gentleman just asked was similar to mine about that get string. I happen to use that particular. I posted it in the chat,
Okay.
and if for some reason the elements they were passing to me on one file had all the elements the same, like we're always passing the same like 6 fields, but the second file I chose, one of the elements didn't exist on some data elements. Like normally you have 10 fields and you pass all 10. It just happened that some of the data didn't have all 10 elements. So for example, in that chat, I had one element that didn't exist and I was getting an error. So, and it was an error 11 that was sort of in your guys' code and I couldn't get through it. So
Okay.
in order to solve it, I just put the whole thing into the array, which was also a nice feature that you guys added. So, and then I just parsed the array. So I
Okay.
just kind of,
I
and
mean,
that could,
if you want to mention, or
yeah,
if you want to talk about that after as well, we can go into it a bit more to see what exactly is happening, just to
sure.
make sure.
But yeah, a neat object, and look forward to using it. So thank you.
That's great. Yeah, part of our user group, when we were talking about it together, was we're looking at the performance of the XML object, and a lot of people have things that are in JSON that they're getting that, they actually want in, or they get back JSON, but they only have the XML object that they use, and so they have to use that and do some conversions. But it's a fair bit slow, so we wanted to add this to kind of fill in that gap. Okay, is there any other questions?
Aaron, I don't know if you have the chat open. Tony had a question there. How about a CSV command to convert the data?
Let's see. We don't have that at the moment, but that is definitely something that we could look into. What else do we have? Not
Aaron, there's another question in the Q&A from Chris Ellis.
Q&A. Okay.
Is there a plan on including XML attributes of an element in JSON?
As of right now, we weren't originally looking at that, because it's a little different from how JSON works in the sense that we have the base tag and it just has data. However, there is something that we could look into that to add a option for handling XML attribute tags as well. Okay. Oh, let me get back to the slide we were on.
It takes a while with all your animation.
Yeah. Okay. So hopefully you're all excited about our next presentations today about PxPlus developer training and our PxPlus roadmap. So I want to thank you for giving me your time, and I hope to see everyone again at our next DireXions conference.